Hey guys, this is Kevin, and today I'm going to be talking to you about ice and its behaviors. So first and foremost, what is ice? Ice is water frozen into a solid state. This happens when water goes below 32 degrees. So ice has two different appearances. It can either be transparent or opaque. Transparent ice looks very clean. You can see through it, and opaque ice is very white and cloudy, and you can hardly see through it at all. And in some cases, you can't see it at all. So ice has many different forms. You may have seen ice as ice cubes, and glaciers, icicles, snow, and hail. So right now you're probably wondering why ice differs in appearance. Understand that many factors determine the appearance of ice. The main factor is the way in which it is frozen. The empty space and air bubbles make ice look very white. Water freezes before the bubbles can escape, and as light tries to pass through the opaque piece of ice, the light is being scattered out because of the bubbles inside, thus giving its white appearance. So why are there bubbles in the first place? Well, the dissolved gases are forced out of the water when water reaches its freezing point. And in a lot of cases, the water freezes too quickly for the bubbles to be able to escape. Let's talk about the behavior of ice. First and foremost is the direction in which it melts. The direction of melting depends on location. Ice melts faster in water than it does in air because molecules of water are more compacted, thus having more contact with the ice. More contact means more heat transfer, and more heat transfer means more heat. The same concept could be applied to solids as well. And what I mean is that if you put a piece of ice on a solid table, it will melt from the bottom up because there's more contact with the table's molecules. Please keep in mind that this does not take into consideration outside sources of heat, like the sun shining on the ice. As I mentioned earlier, the speed in which the water is frozen determines how the ice will look. Also take into consideration what the liquid was doing before it was frozen. A really good example of an object of liquid freezing too quickly and turning into an opaque piece of ice is when someone super cools something. Now let's talk about the different types of ice. One type of ice is icicles, and icicles are usually clear because of how they are formed. They grow as water drips to the bottom and freezes, and by this process, the ice is formed in layers, avoiding any air bubbles that may be trapped. Snow is another one. Snow is white because of its crystalline composition. The direction as light passes through is hindered and scattered into many different directions instead of going straight through, thus making it very white. Icebergs and glaciers are some other examples. They form relatively slowly, yet they are white and opaque. Snow doesn't melt at the poles, but instead keeps stacking together. Gravity compresses it together in the span of thousands and thousands of years, thus creating icebergs and glaciers. Another very common question is why ice looks blue. If one were to look up a picture of an iceberg or a glacier, they would notice that it has a very blue tint to it. A lot of people try to figure it out, and one common misconception is that the blue tint is actually a reflection of the ocean or the sky. Another misconception is that it is because of Rayleigh scattering, the same way in which the sky appears blue to us. Well, none of these are actually true. Instead, ice sometimes appears blue because of how water molecules react to light. When light passes through water, low-frequency lights like yellow and red are absorbed, while high-frequency light like blue and green are actually reflected. Thus, what we see is a bluish tint. The color that we see is actually correlated with the mass, which is why small bodies of water and ice appear colorless to us. But in large quantities, like icebergs and glaciers, the long paths in which the light passes through make the formations look very blue. Alright, I want to end this video by showing you a bad example of ice in a movie. What to look out for is notice how the ice materializes right here.